Okay, so I am back and we are going to be continuing our project where I have my NVIDIA Nano right there connected to my MacBook, and we are going to be continuing to develop on learning how to actually orchestrate all of these AI components. And in the last video, we were trying to figure out, okay, well, we have this model that I wrote in Python, and when we run it, the model keeps trying to use tools even when it's not supposed to. And even worse, it's hallucinating tool. There's three problems. Number one, it's using a tool, it's trying to use a tool when the user prompt, so what I give to it, doesn't require a tool use. Like, can you hear me, for example? Okay. Number two is it is hallucinating tools that I didn't even give it, right? It's talking about speech tools, okay? And number three, it's not even calling the tool correctly. It's supposed to be format here. Let me minimize this. It is supposed to be, if it wants to call a tool, it should be coming in here. I get the user's input, and then I append that to the message, right? And then I come here and pass my, I pass that list of messages into Ollama. Okay. And now if it wants to use a tool, what it should do is in this response, it should have the message, right? Which is what the LLM sends. It should have a field which is called tool calls, which is going to be an array of tools that it wants to use. It's not doing that. It's putting it in the message. Okay? Not tool calls. It's creating a message with a whole bunch of text. And then within the message, it's just writing the JSON. And it's like, that's not what you're supposed to be doing. So we need to go in and start troubleshooting it. I am going to power on my unit and we can get started. Okay. So to remind us where we were, see, it's coming up with a speech recognition, which that's not one of the valid tools. I've given you two tools. Status of lights in room and temperature in room. Okay, just two tools. There's nothing which is speech. That's not a valid tool. But it created a tool called speech recognition and then created its own parameters, which is get microphone status, right? So obviously we need to modify how it's actually grabbing and or who it thinks it is. I think that's the problem. I think it is because I say you're an intelligent chatbot. In the past I was saying you are a smart home assistant, right? But now I want to change that, and I tried this, but it's still, I said you also have access to tools if you find them necessary during conversation. Okay. What I might want to do is, I saw this, right? This example here explicitly says, do not, it has this message here. Okay, so it's system. You're an agent that can request tools when needed. Okay. So, all right. Let's come here and maybe we try to do that. All right. So I am going to come to Gemini and say, here is the output. I am still getting it not to be working as I expect. Okay. Here, paste that in, and then I'll paste the full code here. Okay. Any ideas? Like that. So my model should be up and running now. So let's come into the terminal. Jetson, here we go. And let's just run our Python and we can, right, we need to get into the directory. Where are we? So to desktop, and in desktop it should be there. Okay. Was it exam? Okay, fine. Okay. So now I should be able to run it. So I'm actually not going to say, can you hear me? How is your day going? Because maybe the thing with can you hear me, that's tripping it up, and it's thinking like, oh, okay, well, I need a tool for hearing, you know. The other thing that we can change is possibly the model. So there's a fair amount of thing. Is being too helpful and hallucinating a capability it doesn't have. When you ask, can you hear me, the model feels pressured to act like a physical assistant. Since it doesn't see a check microphone tool in your list, it tries to invent one. Yeah. And typing out the JSON because it knows how tools look. Here's how to fix this logic and behavior. Okay, so keep your current system prompt, or your current system prompt is too open. In the AI world, we'd use native constraints to keep the model on track. So native constraints, I have a list of all of the different concepts that I hear, and I'm thinking, okay, well, this sounds like it has a lot behind it, and I want to make sure that I follow up on it. So native constraints, or negative constraints. Okay, negative constraints. So, okay, negative constraints. All right. Although we are going to follow this up immediately because we need to be able to actually use that. So to keep the model on track, you need to tell it if you don't have a tool for it, don't make one up. So that's an example of a negative constraint. Okay. Update my system prompt. So let's do this by hand, and then, so see, it's loading. But because we changed it in the last video such that we have like timeout is -1. Where is it? Or keep alive is -1. This means that once it's loaded into RAM, it should stay there. Okay. So now what I need to do is I need to update this one. So we're going to say this one didn't work either. This is a bad one. And we're going to write our own, which is this one here. Okay. And I just saw that something happened here. See, it keeps trying to do that tool. Tool call response. What? Since there isn't an exact function provided, call a tool to generate or call a tool to generators. What? Okay, quit. So we're gonna do this, and then hopefully this will stop some of the hallucinations. I can move this over here and need this to be more compact so it's not running off the screen all the time. Okay. So messages is equal to a list and here, okay? And we're going to say, all right, so the role is going to be system. All right, so this is a system message. And our content is going to be a longer prompt. Okay. Is going to be, okay, like this. I don't want it to be a Home Assistant though. We can try it this way, but then I want it to be kind of a chatbot, but also has ability to but also has the ability to use tools, right? You are a Home Assistant, right? Number 1, only use the tools provided to you. So the reason that I'm typing this out instead of just copying it is because I normally, if there's no like learning value to it, then I just copy and paste it. But I want to also know, how do you get those good system prompts in so that we can develop our skills. So number 2, if a user asks for something you can not do with your tools, but now we're like hearing audio, explain that you cannot do it. Oops. Explain that you cannot do it. Okay. I don't think that this is going to quite give the right response that we want. Never, because I don't want it really to be the Home Assistant. I want it to talk to me, but also have the ability to use tools. Never invent new tools or output JSON manually. Okay. So Llama 3.1 is trained to trigger a tool called mode when it sees a match. When it doesn't see a match, but wants to use a tool anyways, it falls back to its general training data, which includes thousands of examples of JSON. It thinks it's doing you a favor by showing you what the code should look like. Okay. So for this one, I'm going to ask a follow-up question because we're trying to investigate everything. So can you explain the actual process of how an LLM decides and triggers a tool call? Go into full detail and yeah. Okay. Go into full detail of the entire process. Okay. Fixing the double response logic. In your code, if the model hallucinates a tool and types it as text, it goes into your else block. You print it and the tool starts over, okay? But if it actually calls a tool, your code does a second check. Okay. Check this logic error. Turn number 1, turn number 2. This part of your code is actually correct now, but the model is failing because your system prompt isn't strict enough, okay? If the list gets too long with fake JSON responses from the AI will keep following its own bad example. Try changing the question. Instead of can you hear me, try is it hot in here? Okay. Okay. Let's do this. And then, so I'll let it run, and now while it's running, we will take this, copy this, and paste it into here. So I want to do, what is it, cat, go into JSON exam. So we're gonna cat this, paste this into there. Okay, and now I should be able to do Python 3 here. Hopefully it will run faster now. What is your name? I don't think that this is going to work because I don't think that the system prompt was correct. Okay. It should have, okay. Status of lights. Yeah, it's not working. The functions however, it does not directly provide information on one's name since it is provided as a... Oh my gosh. Okay. Let's try, what is the temperature in the room? See if it can call it. Yeah, okay, that's right. Okay, yeah. Are my lights on? So it is able to put the tool correctly, like in the response, but it's just always you. But it didn't do it for the status of lights. Okay. Okay. I don't know if it's a thing of like my prompts are incorrect, like my system prompts are incorrect, or if it is a thing with the model is just not the best. Like it's old, or I don't know. Okay, to understand how an LLM decides to call a tool, you have to move past the idea of the AI having conscious choice. It is a strictly mathematical process of pattern recognition and token prediction. All right, yep. Here's the full technical breakdown of how this happens from the internal neurons to the final JSON string. Awesome. That can probably have some coffee. All right, so before you even type your request, the stage is set. When you pass tools to an LLM, the system essentially injects a massive hidden instruction into the system prompt. Oh, okay, so Ollama is injecting another hidden instruction into my prompt as a system prompt. Okay. The model is given a strict JSON schema for every tool. It reads the name, the description, and the required parameters. The formatting rules. It is told if you need a piece of information, you don't have stop talking normally and instead output exactly this format, right? Tool call here. Yep. Okay. Internal reasoning, the decision. When you ask, what is the temperature in London, the model begins generating tokens one by one. Probability. The model looks at the words temperature and London in its training data. These words are mathematically linked to the concept of external data. Is external data up here? And how are they linked? Like they have a strong weight connection to external data? Okay. The logistics spike. The neurons associated with your room or temperature in room tool descriptions start to fire with high confidence. Associated with the temperature in room tool. Okay. The probability of the next token shifts. Instead of predicting a word like the the highest probability token becomes a special token like call or this, okay? Pattern matching. The model isn't thinking, it's completing a pattern. It has been fine-tuned on thousands of examples where user asks X plus tool Y exists equals assistant output JSON. Okay. The structured generation, the trigger. This is where the model acts. It enters a specialized generation mode. Where the model acts. It enters a specialized generation mode. Constraint following. The model starts typing the JSON because it has the schema in its recent memory, the context window. It fills the blank. It knows room ID is a key because the schema told it so, okay? So it's looking at the past histories. Argument extraction. It looks back at your prompt and maps the specific string to London parameter in JSON, okay? If it's doing one token at a time, that's how it gets London, is because it's just keeps going. I'm trying to wrap my head around all of this. The stop token. Once JSON is valid, the closing parenthesis is reached, the model is trained and output an end of sentence token, okay? This tells Python code I'm done, it's your turn. The execution. This is the part that I wrote. So parsing, the Python script receives name, temperature in room parameter, right? My script checks, do I have a function named temperature in room? If so, hand it off, right? But that's kind of abstracted away by Ollama, I believe. And so now it is just given to us, and it's part of, and Ollama just puts it as tool calls, like a list. So it's doing the parsing of the JSON. The loop back, the final answer. The process isn't over yet. You need to send it back to the AI. When your model typed out JSON, but didn't trigger your code, okay, it's because it got confused between chatting and calling. It predicted that the most likely next token were text describing a tool rather than structured data required to trigger your Python. Okay, this usually happens if the model is too small, like 8 billion. Okay, or the system prompt is too chatty. Okay. So I'm going to say this, and then I am going to copy this over. It is still doing it. Plus, I don't want it to be a home assistant. My idea is that it will be a conversationalist, be something that I can talk with, but it also has tools available if it wants those tools. What is going on and how can I fix it? Okay, I'm just gonna say, how can I fix it? There. Okay. We might need to change this. Notice it's not even getting the right thing here. Even the 8 billion is too dense. That sometimes tries hard to satisfy the tool definition in its context window. When it sees a tool, it assumes the primary purpose is to use them, even when the question doesn't fit. The JSON leak. When you type JSON instead of triggering the Python code, happens because the model is failing. The specific special tokens that tell Ollama this is a tool. Yep. Here's how we can move to an intelligent companion while fixing the technical glitches. Number one, the companion system prompt. If you want a chatbot you can talk to, but who also has tools relevant, you need to change the priority. Okay, priority here. Tell it that conversation is default and tools are extensions. Okay, this sounds a lot better. Let's do this. So what if I with better doc strings? Hide it and clean things up. I don't want that because it's gonna... That is going to just make it where we are unable to troubleshoot. However, the best fix for a Nano is to switch to a model that is tuned specifically for this. Is actually sometimes better at following "don't use tools now" instruction because it's less prone to overcomplicating things. Okay, why it ignores your assistant instructions. When you said, I don't want it to be a home assistant, you were right. The model was stuck in a role play trap. Yeah. By giving it the tools, status of lights in room, you're essentially giving it the uniform of a home assistant. To break the cycle, ask it something completely unrelevant first. What do you think about Mars? If it responds normally, your companion is working. If it still tries to check the lights, it means your message history is poisoned by those previous bad responses. Every time you change your code, restart the script. Yeah, we do that though. Okay. So let's redo these things. Okay. We're going to once again do this, and it doesn't like that. So we are going to do this. So messages is equal to, we are getting good at this. Roll. Okay. And system. Yep. And then the content is going to be here, and we are saying that you are ding 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 ding. Okay. You are a helpful, friendly, okay, I like this, AI companion. Oh, I like that. Okay, AI companion. Yeah, that's AI companion. Okay. Talk to the user naturally. Yep. Number 2, you have access to tools for lights and temperature. Only use them if the user specifically asks about the room environment. Okay? All right. Number 3 is going to be if you use a tool, do not output the JSON yourself. Just let the tool run. 4, if you don't have a tool for a request, just answer normally as a companion, right? AI companion. There we go. Okay. So let's copy this and come into my system here. Do the same thing that we always do here, and then we paste that in, and then we do this, and then we run it, and okay, I say, what do you think of Mars? Okay, so what do you think of Mars? And now I put that the model should not leave RAM. Oh, and okay, good. If you're interested in learning more about Mars, okay, here we go. I don't have any information about Mars as it was not provided in the original prompt, okay? But I can tell you that Mars is a planet in our solar system. Okay, so it's better. It's better now. That means I am going to commit. So let's save our work. Okay. Git add, git commit here. So what did I want to say? Just did system prompt to change role of LLM from Home Assistant to AI companion. So that the LLM can talk to me, but also has tools available to it. This seems to make it better at responding in a conversational way. I also updated the system prompt to discourage using tools if not required, and making tools up. Okay. All right, there we go. So we saved it. I'm gonna say, what is the temperature in my room? Okay. Think yes. Should say 22. Well, it said 20 degrees Celsius, and that's not what we gave it. Oh, yes, it is 20. Okay. I thought we said 22. Anyways, what is the status of my lights in my room? Okay, I'm going to be very specific. Hopefully it does lights. Okay, let's see if it gets it correct. Are currently on. Yes. 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 It's working. Here we go. Tell me a story. Tell me a story. Okay. So something completely unrelated. Ah, darn. Tell a story. No. It decided that it was going to create a okay. What are the different models available to me? And what is the best for my Nano 8GB? Okay. I'm thinking maybe it's a model thing. Is behaving more like a companion and less like... Okay. On an 8GB Nano, your budget is tight, yeah. Because share the same memory. Yeah, okay. Seems like this is going to be... my recommendation... Llama 3.2. 3 billion. Okay. For a companion you want to talk with, is currently the champion for your hardware. Speed, it will feel almost instant, whereas 8 billion feels laggy on a Nano. Stability, because the tool uses less memory, it won't swap data with the slow micro SD card, which prevents model from getting confused and outputting garbage. JSON leaks is dense. When it's crowded in your VRAM, the attention mechanism, the part that helps the AI focus on your instructions, can get degraded. It sees the word lights in your code and its internal wait trigger and its internal waits trigger a tool call pattern so strongly that it overrides your do not talk about JSON instruction. Okay, yeah, so it's seeing that I gave it the tool, and that is strongly associated, like that's more strong than the do not talk about JSON thing. So stop the old model, right? So Ollama stop. All right, so let's do this. Let's quit out of here. Let's go Ollama stop, and then Llama 3.1, and then 8 billion. Okay, we're gonna stop this. Okay, there we go. Llama pull Llama 3.2. Do we need to specify the parameters, or... Okay. So that's going to be running, takes a little bit. 2 gigabytes, and this is going on the SD, so it should be okay, right? update your code for 3.2. All right, so now we're going to come here and say, instead of this, we are going to say 3.2 here and 3.2 right there, right? Is that the only time that we use it? I think so. Okay. Okay. So this is definitely good. We're learning a lot about how these models actually have tools. I need to be able to try to, because my ultimate goal that I really want to create with this is I want to be able to, does it have, although you can't really right now, RAM is like really expensive, but I don't even think that it's possible to upgrade it with RAM. I think it's just static. So darn. And we can't get a more expensive one because I don't have the money. um okay, so anyways, we're gonna have to make do with what we have, but I'm trying to think, how do we actually go and my ultimate goal for what I want this to be is I want something that I can talk to. I'm gonna attach, I want to be able to talk to it, so I need to like use Whisper is what I'm imagining. Is I have a speaker attached to here, a speaker and a microphone, and I talk to it, and then I use Whisper to transcribe the words which I say into text, okay? And then from that, I put it into the LLM, and then from that, I am able to get an output so it can speak back to me, can talk to me, okay? That's what I'm imagining, that's what I'm hoping for. And then I can give it tools to say like, okay, well, you have this tool and that tool and the other tool. So like if I talk to it and say, hey, can you turn off my lights? And then I write a tool, but instead of like this, it would be actual code that I write to be able to interact with the whatever, if I have a Wi-Fi drive or on my lights. That's kind of my idea of how I want to go about this. So, yeah. Okay. Let's see if everything is pulled. No, it's at 76% now. Okay, so how can I want to determine, so now I'm starting to understand like, okay, well, system constraints, right? This is very much like an engineering problem of like, how do you operate within system constraints? I want to see how much memory I actually have. What are the commands which, I think it's that JTOP, which I can use to determine how much memory I have in my Jetson Nano. And what does this, okay. I will output those command results to you and let you investigate what this means about my system. Should I have the model in RAM when I do the queries or not? and how would I do that? Okay. All right. So it looks like we got it. To see exactly what's happening with your memory in the Jetson, you should look at it from two different perspectives, the Linux system view and the Jetson specific hardware. Okay, so you should run these 4 commands. Each one gives us a different piece of the puzzle. So free H, this is the standard Linux snapshot. It shows your total RAM, how much is actually used by programs, and how much is being used for buffering caching, which Linux clears out instantly if it needs to, okay? So JTOP, I don't think we have this. Since the Jetson has unified memory, okay? What is unified memory? Your 8 gig is shared between the CPU and the GPU. Okay, that's what they mean by unified memory. The 8 gigabytes is shared between these two processors. Standard Linux commands can be misleading. JTOP will show you how much of the 8 gigs is currently being used by your GPU shared memory. Okay. Cat and then proc meminfo grep iswap on an 8 gig board running LLMs, you are almost certainly using swap virtual memory on your disk. This command tells how much the system is cheating by using your SD card as extra RAM. Okay. I'm really thinking that I need to upgrade my system to have I forget what it was called. Like, is it something that you can add some extra thing here? Ollama PS, this specifically shows which models are currently residing in memory and how much VRAM they're taking up. I believe if I do JTOP, it's not there. So yeah, I need to, this is a Linux one, and like apt install is going to go to the Ubuntu standard. How do we get this? Okay. So you should do, okay, so we should load and, we should have a loaded and unloaded. You should do both. Number 1, cold baseline. Run the commands before you start the script. Okay? This tells me your idle state, how much memory your OS and background apps like desktop GUI are eating. Okay? Hot state. Run the commands while your script is running and the model is loaded. This will show us the delta, exactly how much pressure 3.1 is putting on your system. How to keep the models in. Okay. By default, Ollama kicks them out in 5 minutes. To keep it loaded for your investigation, run this in your terminal. Okay. This will load the model and lock it in memory indefinitely. You can then open a second terminal and run diagnostic commands. When you finish investigating, unload it with stop. Okay. I don't want to. Okay, fine. I was thinking I don't want to log in again, but then I realized that's actually really simple. 0 JTOP will show is fighting for every. Okay. So what I want to say is, first I'm just gonna say this, like, we'll let it'll know what to do. Okay. Sudo apt update, install Python 3 pip. Okay, so we're gonna install pip. Okay. And then we need to reboot. Whatever. Okay, fine. Let's see if we're able to get it. Or if we get an error. Upgraded 0. Okay. Everything seems to be in order so far. Okay, Jetson stats. Awesome. So, oh, now we need to reboot. Sudo reboot. Okay. So we'll let it do its thing. It'll come back up, and we will start that off. Okay. All right. So let's do this. We're going to try to SSH into it. I don't know if it has come up yet. Apparently not. Are you up yet? Okay. Well, there we go. Jetson. There we go. Awesome, awesome. So I'm going to come here and I'm going to say we're going to go into desktop and then into, oh, what was it called? This one, and then examples. Yeah, I'm going to come into here. And now what we are going to do is we are going to do this. Free minus H. Okay. Maybe I should actually expand this out so it's a lot easier to see. Okay. So free minus H is this. What do we see? Memory is the 7.4 gigs. Used 1 gig. Okay. Free is 5. So it seems like this is what the OS is using. OS and everything. Okay. So that's that. And then we can go JTop. Hopefully it will find it. Oh, and this is interactive. Awesome. What do we see? NVIDIA, Jetson Orin Nano, Engineering Reference, Developer Kit, Super. Okay. Linux for Tegra here. C123. Is this CPU? Like Core 123? User here, memory. Where are we seeing GPU? GPU here is temperature. Okay. CPU here, CV 0, 1, and 2 are offline. GPU is here, right? Jetson clocks. Okay. So I should be able to, can I just quit? Okay. Maybe I should have taken a screenshot of that. Hold on. Not screenshot, but just like. There's not a way to do that. Okay, fine. Here, I don't know if I can. Oh, okay, I can. I didn't know if it was going to not let me do that because I'm recording a video. But I have this, okay, and now take you and put you in there. Creating content. Make sure that you have that. Yeah. Oh, come on. Yo, okay. 真的是烦人，我靠。 Are you going to work? No, you just don't work. Okay, fine. Fine. That's okay. That's great. That's awesome. Okay. Okay, what if I just one more time? I'm gonna try this. I have to be fast. I don't like. I wish that I could just copy this. Let me try one more thing. This is one of the things that Mac is definitely not good at, which is their screenshots. Okay, can I come in here? Can I do copy? I cannot even do copy. Can I drop? Oh, it's hard. I don't know. Okay. Copy image. There we go. Okay, only took me 10 times. Okay. Quit out of this. Now, let's, we're gonna get this, right? Paste that into there. And then, what are the other ones that we're gonna do? JTop, so we got that. Then we are going to do this one. So cat, this proc, whatever proc is, I'm not sure, mem info, and we are specifically searching for swap, whatever that means. Okay. So this is all the unloaded stuff. Okay. Ollama PS. All right. So I believe this tells me what's loaded, right? Specifically shows which models are currently residing in memory and how much VRAM they're taking up. Okay, so now I'm going to say now I will load the model, right? So what I want to do is I want to create a new terminal, and I want to say new window, right? And I want to do the what is it? SSH into timothy@jetson.local. Okay. Jetson. All right, there we go. So now we have two terminals open, and I should be able to, from this one, I will need to come in here, right? And I want to do my Python. Okay, I want to do my Python. Python 3 and this one. Okay. How is your day going? Like this. And now I'm gonna do this. I'm gonna let it do a response, just a response, okay? And then by that time, the model should be loaded into my memory. Model loaded, which is Llama 3.2, which you suggested to me. All right, So then I am going to come here and wait for this to load. It usually takes about 1 minute, about 60 seconds, somewhere around there. Then we will ask it a follow-up question and see how long it's taking. Okay. Actually, we can make this a little bit smaller. Where did my other terminal go? There it is. Okay. Make this smaller because we actually don't care about this one right now. This is the one that we care about. And actually, I should have those commands kind of quick. No, okay, fine. So free minus h. Okay, this is the one. What was the other one? It is cat proc mem info. Okay. Grep minus I swap. Okay. Is that what we got up here? Yeah, somewhere around there. Okay. And then the JTOP. And then Ollama PS. Okay, this is the other one. Okay. So these are the commands which we want to use. So I'm going to do clear. Okay. Like this. And what we're going to do is we are going to write a prompt into here. So I don't have a specific, so it's still trying to get that function thing, even though we're using the other one. So it's still low, or like biasing too much towards the tools. Doesn't require. If you don't have a function to call, we say like, if you don't have a tool to call, just answer normally. Normally. Okay. Anyways, let's tell me a story which you find there, go, and now this one, Ollama PS, this one, and this one. Okay, and now JTOP here, and now this one. Come on, please, quickly. Okay. Ah, we missed it. We missed it. Okay. Okay. Now what we're going to do is we are going to, we're going to say, I love that story. Keep telling me more about this story. Okay. So we're going to press this and we're going to watch what it does. And then we're going to try to get it quickly. Okay, so press enter and now do this. Okay. And it's going to run, and I should be able to do this. Go. Okay, click you. Okay, yes. And awesome. That is kind of exactly what I was hoping for. Okay. Okay. So now I want to paste that into there. Okay. Here we go. And so it's doing status of, that's not what we want, but fine. Fine, fine, fine. So now I want to copy these three. Okay. Good, we got our statistics. Ah. 我操！好生气的，我靠！It deleted those images. Okay, fine. I don't care. I don't care. I don't care. That's so annoying. Okay. In your data, look at available memory in the free.h output. Before loading, it's 6.1 gigabytes. After, it is really small. Okay, you have less than 1 gigabyte of breathing room left. When your available memory drops this low, Linux starts panicking. It begins moving background tasks into swap your micro SD card, which is thousands of times slower than RAM. Yeah. Why this breaks the AI brain. Okay, when an LLM runs tool calling logic, it needs a bit of extra working memory, KV cache, to hold the tool definitions and its own thoughts. Your Llama 3.1 is taking up, but this is the 3.2, the smaller one. 5 or 6 gigabytes, okay? Your system desktop is taking up 1. You have total. Because you have the 7.4 total, there's almost no room left for the AI to think about the tools. When it runs out of the scratchpad space, it stops following the complex instructions like tool calling and falls back to simple generations, printing JSON like a typewriter. Okay. Look at your Ollama PS here. Wait, why is it doing the 3.1? Oh, because we didn't change it, right? Okay. Hold on. Let's change this. So sudo stop or ollama stop, and then llama 3.18 billion, right? I think that is the command. Yes. Okay, so now I should be able to say ollama ps. Okay, good. Now I can say free h like this is now going to be here, right? Okay. So now what I want to do is I want to come in here and I want to copy all of this, and I want to, actually I want the other one. I want to come in here and I want to quit, and then I want to cat here. Okay, I want to paste all this stuff in. I want to then run this model, right? So now we run a different model. Tell me a story. Tell me a story. Okay. Let me just JTop. Okay, let's see if I can do this here, right? And now GPU is still at, oh, right, that makes sense because it's loading it into the RAM right now. Okay. Okay. We should see GPU spike when it starts actually. There we go. Right there. Right there. That's what we want to see. Ah, and it was so fast too. It was way too fast. That sucks. And it didn't even do it correctly. Oh my goodness. This is not good. This is a little bit disappointing, honestly. Okay, this very disappointing actually. The solution use 3.2. That's what we're using, right? 3.2. Enable ZRAM. Oh, this is annoying actually. Okay, so let's come here and key. Don't use a tool. Just talk to me as a friend. Okay. GPU spikes, and there. I got it. Okay. Here. Copy image. And I am just going to do this. Something went... yeah, Google's Gemini has been horrible for the past, like, 3 or 4 days. I don't know what is wrong with Gemini, but it can't do... like, it lost all of my data and all of my conversational history. Yeah. Maybe it doesn't like it because I'm signed in, because I thought that I could do images at least even a couple days ago, right? But, yeah, I can't copy and paste any of this. What does 7 do? Copy and paste this? No. 6. 5. 4. 3. 2. Okay. Well, see, now it actually, when I specifically said, don't use a tool, talk to me as a friend. Okay. What else did Timmy do? Okay. Should see the spike, right? Okay. 100%. So this is time. Shared RAM. It doesn't go too high right there, right? CPU. Okay. Here. We're at 98%. That doesn't mean... Okay, so let me quit out of this, and we're gonna try the other ones. So whatever, the free. So we're gonna try this one. We're gonna try the free one, and we are going to try the other one, whichever one it was. Try that. The along, yeah. Okay. So now, so this one is 2.8 gigabytes, so it's much lower. Okay, so now, did Timmy go into a mountain? I don't know. Mountain, like, do this, okay. Do that, and now I should be able to do free. Okay, like this. Is it still here? Yeah, those numbers look consistent, right? Okay. But what did it call the tool, right? That's a little bit weird. Anyways, whatever. Okay. But it's talking about the ZRAM. Okay, the numbers don't lie. Look at the transformation in your system's health. So, the processor Uloma 2 is at 100% GPU. This is the golden state. It means the entire model fits in the Orin Nano graphics core, okay? It doesn't have to talk to the slower CPU or swap for its weights. Okay, available memory. You went from 7.38 danger zone to 3.3 gigs available. Where do we see that? Oh, okay, here. 3.5? Where do we see 3.3? And then up here. Is that what it's talking about? Well, hold on. Buffer cache. Okay. What is this? Mem and swap. Let's first, before we do this, let's investigate what all these things are, right? So mem info, swap cache, swap total, swap free. And then we're going to talk about this JSON lake because it keeps talking about that. I thought that it was just, I didn't recognize that this was like an actual topic thing, but it keeps talking about it. So I need to investigate this as well. So I'm going to say follow-up question number 1. Can we go over every single field in those diagnostic commands which you told me to run? I want to know what those numbers indicate. Numbers and fields indicate. Okay, that's number 1. Number 2 is I want to know about what you are talking about with ZRAM or something. ZRAM. Okay. Number 3 is going to be, got this, fix your JSON link. LLMs are like athletes. They need oxygen to perform. In AI terms, the oxygen is KV cache. Okay, I need to look up KV cache and understand how this is working. When you ran the 8 billion model, the room for the AI's working memory was tiny. It would start a sentence, run out of memory, and its logic would collapse into printing raw JSON. I was under the impression that if the model was unable to, get enough memory, it would not affect the final result of the calculations, but rather just throttle the speed at which it runs. Okay. It would start a sentence, run out of memory, and its logic would collapse into printing raw JSON. But you are indicating that this memory, this RAM throttling is actually impacting the output of the LLM, like this. It can now easily hold your system's instructions, tool definitions, and conversation history simultaneously. Okay, the next task. Now that this is loaded hot in your RAM, run the Python script again. It should respond like a friendly companion, and then it should do this. Okay, note on JTOP. Once you finish rebooting JTOP, keep it open on the side. You'll see Ollama uses 2.8 gigabytes and leaves plenty of room for you to even open a browser or VS Code on the Judson while the AI is running. Okay, would you like me to show you how to add history limit to your code? This will prevent message lists from growing too large. Okay, not right now. So this is later. 4, I heard that I can attach some other form of memory to my Judson. What is that? And do you advise it? Okay, so I think that was like solid, like SSD. Not the SSD card, but it was some type of like disk space essentially, but permanent memory. And I don't know if that would be better or worse, or like how that would affect. But yeah, so okay, and would you advise it? Okay, so that's one, and let's see, what else should I ask it about? I don't know. Okay. History limit, thinking, holding everything together. Okay, that's fine. That's fine. We'll just do this, and once we get done with this, all right. So this is the hardware versus software interaction that defines working with edge devices like the Judson. All right, when you run FreeH, you are looking at the kernel's bookkeeping. Here's what those, that's what I was trying to do, is JTOP does not allow me to copy and paste things. Is there a way to do that better? Okay. Darn. I just want a snapshot of it. Here's what, okay. So let's look at FreeH. So this one. Okay. We have total. We have used, we have free. We have shared, we have buff cache. And we have available. Okay. So the total physical RAM soldered to your board, 8 gigabytes right there. Okay. The used is the physical RAM is memory currently held by active processes, which means Ubuntu, Ollama, or Python. Okay. Free is right here, megabytes, but this megabytes plus this does not equal total. Hold on. Oh, available. Okay, then what's free? The memory that is completely empty. In Linux, free is wasted space, so the system tries to keep this low. Okay, fine. Shared. Memory used by multiple processes to communicate, mostly used by desktop GUI. That's another thing which we might be able to do, which would be to disable the Jetson, or disable the Nano GUI. We might be able to do that and free up a little bit more memory. Although my concern with that would be if we did that and then for some reason I was unable to SSH back into it. I don't have I can't have a GUI anymore, and right, like there's a little bit of danger there. It could just be something that I just do every time I log in, something like that. So I can't edit a cron tab, because if we do that, then it will. Although maybe I could. If I'm unable to SSH into it, I would still have the boot up screen, and from that I could do something. Okay, so I guess follow-up question number 1 is going to be for the I am able to get JTOP, but I am unable to to copy and paste it into you. Is there a way to get that data printed to my terminal so I can give it to you? Okay, that is follow-up question number 2, number 1, number 2, and we're gonna read through this, but I'm just trying to make sure that I don't lose them. And I already lost what number 2 was. Number 3 was going to be that one about I am running my device, my Nano headless, so I don't need the GUI. But I am concerned about if I lose the ability to SSH into it for whatever reason, I will then never be able to get back into the system. What would you advise me to do? Okay. This one is, I forget. I was going to ask a question. Maybe we just keep reading and then we'll figure that out later. Okay, so free, that tried to keep, right. This, so like swap cache, swap total, swap free, mem, and swap. I keep seeing swap all over those commands. command results. Can you go over in detail what these swaps are about? Okay. So yeah, shared. Okay, so memory used by multiple processes to communicate, mostly the desktop GUI. So shared is so small, right? I am also seeing that shared is only 11. Does this mean I would only save 11 if I disabled the GUI? No, not guy, GUI. Okay. Alright, so buff cache. This is smart memory. Linux uses it to store files it thinks you might open again. If a program like Ollama needs more RAM, okay, the system deletes this cache instantly to make room. Okay, well, hold on. That, I just got another one in my head. I know that persistent memory has a finite read/write cycles. Am I wearing out my system? Okay. All right. So smart free memory. Linux uses it to store files it thinks you might open again. Okay. So cached. Okay, yeah, that makes sense. Linux uses, awesome. If a program like Ollama needs more RAM, so if it's saying I need more memory or more RAM, the system deletes the cache to make room for it. Okay, that makes sense. And how much do we have? We have 2 gigabytes buffered. Okay, it's pretty good. And we have 3.3 available. This is the most important number. It tells you how much RAM you can use before your system starts lagging or crashing. Okay, what is ZRAM? As a compression engine for your memory. Okay. Normally, if your RAM is full, the Jetson moves data to the swap file. So this is swap right there. Swap free, swap cache. Okay. On your micro SD card. Because SD cards are slow, your AI becomes sluggish. With ZRAM, the Jetson creates a compressed block inside your RAM. Instead of moving data to the disk, it zips the data and keeps it in RAM. The benefit, you can effectively turn 8 gigs into 12 gigs of functional memory. Okay. The cost, it uses a tiny bit of CPU power to do the zipping and unzipping. On the Orin Nano, this is a trade-off you definitely want to make. Okay, awesome. That is, here we go. So ZRAM, okay, so ZRAM, here's another thing. Negative constraints and ZRAM. Okay, ZRAM. Awesome. So, does RAM impact accuracy or just speed? In classic computing, like a calculator, I am correct. Low RAM makes it slower, but LLMs are different. When an LLM runs, it needs memory for 2 things. Number one, the weights, right? The brain's, or the model's brain. Second thing is the KB cache. The model's working memory for the current conversation. Okay. Did I write KV cache specifically? Yeah, I see that. The model's working memory. If the KV cache gets throttled or evicted because the RAM is full, the model loses the context of your previous messages. It forgets the tool definitions you passed in. It starts hallucinating like the JSON leaks you saw because it can no longer hold the complex if-else logic of your system prompts in its active memory. Low RAM doesn't just make the AI slower, it makes it dumber because it loses the ability to pay attention to its own rules. Okay. Adding extra memory. The other memory you heard about is likely NVMe SSD, a small stick used in laptops. Your Orin Nano has a slot underneath the... Yeah, here we go. So how it helps, you can create a swap file on your SSD. While SSDs are still slower than RAM, they are 10 to 50 times faster than micro SD card. My advice, highly recommended. All right, running a Jetson off a micro SD card is like putting a bicycle tires on a Ferrari. I wouldn't consider this a Ferrari though. An NVMe SSD makes the whole system snappy and prevents the hanging when it hits memory limits. Okay. So maybe I'll look into that as well. Number 5 is just what would be the process of switching over to the NVMe? No. Right now, my entire OS is on the micro SD card. Okay. All right. Okay. Diagnostic data without the GUI. Since you can't copy paste here, you can use command line version to dumb down JTOP, page info, or JTOP batch. Let's look at those. So I'm going to come here and I'm going to do JTOP and then page info. Let's see what this does. Minus P page. Minus P, I think we wanted 1. Well, I don't want it interactive, but okay. Oops, quit. JTOP and then batch. Yeah, it's not one of these. Whatever. The truth about swap, think of swap as overflow parking lot for your RAM. So we kind of talked about this in the last part above. Oh, when your 8 gigs of RAM. When your 8 gigs of RAM, the fast disk is full. Linux takes the programs you aren't using right at this second and moves them into the SD card. I see, okay. The problem, micro SD cards are 100 times slower than RAM. When your AI model hits the swap, it doesn't just slow down. The latency delay causes the LLM's logic to time out or fail, which is why you were seeing JSON leaks. Okay, I'm starting to understand what the actual problem is. Now that I'm getting kind of the conceptual idea of what the constraints of the system are and how those constraints actually impact the logic of the systems which we are running. Okay, shared memory. This memory is being used by the GPU and CPU simultaneously for specific small tasks. It's not a measurement of the GUI's total weight. Disabling the GUI will actually save you around 1 gig of RAM, regardless of that. Going headless. You can safely disable the GUI without losing access. SSH runs as a... well, I know I can, but I'm not talking about I'm afraid that I'm going to lose access because I disabled it. I'm meaning in the future, if I did this... Okay. I mean, that's what we're doing right now, right? Well, I mean, it has the GUI. Actually, I mean, I am worried about the scenario in which I disable the GUI and then later on end up changing settings or losing the ability to SSH for whichever reason. Like a software update on my Mac or etc. Then I am in a situation where I can no longer SSH into it, and I cannot take my device to a monitor because the GUI is disabled, and therefore my device is completely bricked. Okay. So we could do this, the safety command, do not uninstall the desktop, just tell the system not to start it. So sudo system control set default multi-user target. How to get back in. If you ever need to log into the screen again, just plug in a monitor and type oh, okay. Oh, I guess I could type, yeah, I could type in, because it still has access to the USB, right? So it's still, but from what you are saying, in this situation, I would be able to attach a monitor and a keyboard, then what would it be, like Command T? Start typing on the keyboard, even though there is no display my keystrokes still go through the USB and are recognized by the OS. And then I can type sudo start this, okay, whatever display manager is, via the terminal or setback. And my graphics will come back up. How would I, okay, I'm going to say, is this correct? How would I even get into the terminal? All right. Yes, but slowly here. Total bytes written limit. Every time your system swaps the data in the card, it writes and erases cells. The risk. Micro SD cards are not designed for the constraint thrashing of a Linux swap file. If you continue to run heavy LLMs on your SD card with high swap usage, the card will likely fail within a year. Okay, I see. That's the time frame. This is exactly why an NVMe SSD is recommended. They're designed for millions more write cycles than an SD card. Switching here, you don't have to start from scratch. You can clone your SD card to the SSD. Okay. So install the actual NVMe memory into the M2 slot. Okay. Use lsbulk to find the drive, so the NVMe drive, okay, and format it to Exit4, okay. Does this mean it's bootable, or like what does that mean? I'm not sure yet. So use a script like copy root to USB from Jetson Hacks or NVIDIA's Flash to move files. Redirect. Edit boot exit Linux here to tell the Jetson to use the SSD as the main drive. Okay. Once you have the SSD, the best setup is to keep the bootloader on the SD card, but have the OS and AI models live on the SSD. Okay. Okay, so the bootloader is going to be on the SD card. Awesome. Okay. Let's do this. And now, alright, so disabling the GUI does not disable the display. Okay, so the safety net. When you disable the GUI here, your Jetson doesn't just output a black screen. It switches to TTY, teletype interface. Okay, I want to look that up. What does teletype interface look like? Let's see what this looks like. Teletype interface Linux. Does it have a oh, okay, maybe like this. Wait. Oh, okay. Oh, if it's like that, that's completely fine. Okay, what you see when you plug in a monitor and keyboard, you will see a simple old school text login prompt. white text on a black background. Yeah, okay, good, good. Okay, asking you for your username and password. How to use it. You log in, uh, you log in just like you do with SSH. Once logged in, you're at the local terminal. Okay, from there you can run sudo. Oh, okay, then you're you are never blind. Even without the GUI, the Linux kernel provides several virtual consoles. If one freezes, okay. Yeah, IP address changing. That's what I'm wearing. Okay. So let's just do this. Let's disable it. Okay. So let me come here and let me try this. So this is what we have before, right? So clear, and I'm gonna say free -h, and I am going to say seems like the one which we are most concerned about, right? Okay. So now I want to say sudo system control set. I don't know if we might need to reboot actually. Set default multi-user.target. Okay. Does this look right to disable the GUI? How is this command operating? Do I need to restart? Okay. All right. Yes, that's the exact command. Okay. When you start up, don't go past the... So it's saying, when you start up, don't go past the text-based login, multi-user mode. Okay. To apply this change, you must restart. We'll say in the terminal freeing about 1.2. Okay. Okay, let's do it. Jetson. Okay. Removed. Okay. Just gonna copy this, and in case anything goes wrong, now sudo reboot. Once this comes up, hopefully we will be able to get it. Alright, it's gonna do its thing. Oh, I shouldn't. It's 7 o'clock already? Oh my goodness. Okay. Anyways, I've been making videos for all day today. That's fun. So I am going to see if this works. Hopefully we will see that memory is lower. So I mean, I feel a little bit uncomfortable because I don't really know exactly what that... I know we're doing something with the daemon, right? But I don't know what the, like, multi-user.target is supposed to be. Okay. Okay. So is 6, and it was wait, that oh, available here. Right, we want to keep this low. Then why is it so high right there? Okay. Rebooted. Oh, I forgot to ask the questions. Massive playground. Okay, so by disabling the GUI, you recovered 1 GB of physical RAM. You asked how this command works. So Linux run levels in Linux targets define what service start at boot, okay? Graphical targets loads the display driver, the X11 Wayland server, and the GNOME desktop. Okay. Multi-user target stops just before the graphics layer. Okay. It starts everything else, your network, your AI tools, and SSH. Okay. Your Jetson is now dedicated headless AI server. It uses less power, generates less heat, and keeps your RAM free. Awesome. So now, even though you have this, the Jetson is still using a safety net called ZRAM. You can see the details of this compressed memory by doing this. This takes a proportion of your RAM and zips the data inside of it, effectively giving you about 1.5 more than the 8 allows. Let's look what this just outputs. Okay. So follow-up question number 1 is, I noticed in my free that I now have 6.3. Okay. But you told me that we want this number to be as low as possible. Okay. So now, here, what does this tell you, and what are the fields? So let's see, we had available 6.8, available 3.2, although the model is not loaded right now actually because we just rebooted, right? So this one is closed, and I do want to investigate like what it did. But so if we do like llama, what was the command to keep it in there, right? What was that command? Llama load or something? It's all like hardware kind of stuff right here. Okay, we might be able to do that, and it might. System kernel, Tiger graphics. Okay, we might be able to do this one. See what this gives, right? What happens if we just do it without anything, right? Just like this. Okay. sudo Jetson no such file or directory. Okay. Ollama stop. Here we go. Ollama run this keep alive. Here we go. So now I want to do this. We don't want this. We want 3.2 keep alive, right? What am I on? 3. Here. Okay. Wearing out the system, processing. Okay, we'll deal with that later. We'll deal with the NVMe memory later. Okay. So low memory confusion. I should clarify, you want available memory to be high, but free memory to be low in a running production system. Okay. Free here is the RAM doing absolutely nothing. It's wasted in a perfectly tuned system because it could be used for doing other things. This is your budget for AI. Okay. Now that you have the 6.8 gigs available, when you run Ollama 3.2, you will still have 4 gigs of breathing room. Previously, you had almost 0. This is a massive win for your agent stability. So another thing that I'm a little bit concerned about now is eventually I want to use Whisper to be able to transcribe my voice. Okay, so I'm going to ask that. Eventually, I want to be able to use Whisper to transcribe my voice into text and feed that into the LLM in my Python. How much RAM do you expect this to take? Do you think it is feasible? Okay. So here, your Jetson is using ZRAM, compressed RAM. Instead of writing to your slow micro SD card, here's what those columns mean for your system. So disk size, the maximum virtual capacity of the swap. 3.8 gigs, sum of 6. Data, the actual number of data before compression, basically empty, okay? The size of the data after compression is like 400 bytes, okay? The actual physical RAM being used for this swap is also very small. How many CPUs can be compressed at one? All 6 of my Orin Nano cores. Takeaway, your system is currently so healthy that it hasn't needed to zip anything into the swap yet. So it's staying in the lightning fast regular RAM. Fixing the Ollama error. Is a parameter not a standard flag like here? To keep the model loaded forever. Wait, then what did I do? Oh, okay. Whatever. Let's, and -1, right? Okay. time missing. Since your RAM is now optimized, the last bottleneck is the disk space. Let's just do it a little bit easier. I am going to go into my desktop and I'm going to go into my AI and examples, okay, and then Python 3 here, and then I'm just going to say, hello, can you tell me a story? And then this will force it to load. I guess that means that I need to get another one. So new window, because I want to investigate this as well. SSH at jetson.local here, and then I can say whatever jetson, right, like this. And it's still doing this. This is so annoying. This is so annoying. This is very disappointing. I was hoping, I had a lot more high hopes for this system. Honestly, it's kind of letting me down a little bit. Okay. It's still doing the trying to use a tool, even when I just ask it about telling a story. And it's creating random stories. I'm going to say like this. Okay. I want to... Should I do JTOP? I don't even know anymore. I really don't know. Here. Whatever. So it's loaded, and now we have 3. And previously we had 6, but we still have 3 available, right? So it doesn't seem like it actually saved anything. Here is my memory after I created, or after I loaded the model of Llama 3.2. Is feasible on your Jetson, especially if you've already cleared out the GUI and have roughly this much. Because the Orin, you can run the LLM and Whisper simultaneously if you choose the right sizes. Estimated. Okay, so on a Jetson, you should aim for tiny or base models. The medium or large models will almost certainly crash your system. Good for clear English. What if I also want Chinese, though? Better for accents. 2.8 gigs. This one, this one, this one. Okay. Avoid the standard Open API or OpenAI library and use Fast Whisper or Whisper.cpp. They are optimized for NVIDIA hardware and use less memory. Okay. The board doesn't have a built-in microphone. Yeah, this is what I was going to do. I was just going to do like a USB microphone. Okay. And then number 2, what if I also want to be able to speak to my device in Chinese. And then we're gonna have to figure out why it's doing this. That's not fun. That is really not fun, honestly. But this one did end up giving me at least something, right? Okay. So it was actually giving me a story. I forget even which model this one was. And at least it's not trying to call a mod or call a tool. What else did Timmy do? And then it randomly calls a tool, but then just goes on. Oh my goodness. Okay, actually, we might be able to see it from here. Which model I'm using? The 3.2? Copy all of this, and we'll paste this into here. Okay. Your memory profile looks almost perfect. You have 3.8 gigs of available memory and 0 byte swap used. This means Llama 3.2 is still running entirely in your fast RAM, leaving plenty of room for Python script and future expansions like Chinese speech. Okay, so if we want to do Chinese, running Whisper for Chinese is just as feasible as English because Whisper is trained on massive multilingual data set. The process is identical. So for Chinese, I strongly recommend base or small Whisper. I want to be able to do English and Chinese though. Like memory impact. A base model will only take up very small. Looking at your current here, you could easily load Llama base and still have this. Can LLM speak? Yes, is surprisingly good at multilingual conversation. We already tested that in the last video. If you speak Chinese to it, it will reply in Chinese automatically. If it doesn't, you need to adjust the system prompt. Okay. To get Chinese voice to text, you will need want the following paths. Fast Whisper, it has built-in support for selecting languages. Okay, awesome. So ZH for like 中文, which means like Chinese in Chinese. Encoding. Ensure your Python script uses UTF-8 so that the Chinese characters don't turn into garbage. Okay, yeah, that makes sense. Audio, you'll need a USB microphone that handles clear input, as Chinese relies heavily on tones, which can be lost on very cheap. Oh, okay, that's actually a really interesting point. Because normally when I like speak Chinese to LLM on my phone, it doesn't matter about the tones, because even if I misdo the word, the model is so big that it just kind of does its own thing, right? It knows what you're saying, just like how I can type something and even if almost every word is misspelled, it still kind of gets what I'm trying to say and gives me the correct output. But if we're running on something that's really, really small and I'm talking and it says like, oh, his accent is causing it to go in, choose a lot of very incorrect words, we can have a problem. Okay, your next step. Since your memory is so stable, you are ready to start coding. Okay. Let's do this. so in your first prompt here, what happened? Tools and felt pressure, it hallucinated. The temperature trigger, the third turn. You asked about Timmy. Yeah, I purposely did that. And the model suddenly triggered temperature in room. Why did it do that? LLMs work by pattern matching. In your code, the tool definition are always sent back to the model because the model's brain is small. It sometimes sees the mention of room, the castle, the cave, and the neurons fire. Okay, I see. Observation. Notice that even after it ran the tool, it continued the story perfectly. This shows your loop is working. The model successfully took the output, 20 degrees Celsius, and wove it into the next response. Yeah. Improving the agent logic. So tool description. Change the function docstrings to be more restrictive. Only use this tool if asked specifically this. Don't use for general storytelling. Okay. All right. So I'm gonna leave the video off here, and then yeah, I have a few things that I'm gonna be looking up. I need to start like I'm gonna go and maybe watch some videos to try to understand how to get an LLM to actually like not hallucinate and see if there are good ideas. And in the next video tomorrow, we will be back and continuing to work on this project. So thank you guys for watching this video. If you want to join me on this journey, subscribe. I would love to have you around. Yeah, my name is Timothy Lee Grant, and I'll see you guys tomorrow.